we've done separable equations where you can separate the variables, get your x's with your dx and your y's with your dy's. All right, now we're going to look at a type of equation that's going to be linear in form. So, all right, a sub 1x dy dx plus a sub 0x y equals g of x. This is an equation that is linear in y because y and its derivative are to the first power. Y and its derivative are to the first power. If it were of the form, and I'll do b's, b sub 1 of y dx dy plus b sub 0 of y times x is equal to, oh, I guess I'll just do h of y. This equation would be linear in x because x and its derivative are to the first power. All right, when you solve an equation that is linear in form, the first thing you have to do is put it in what we call standard form. And the standard form for the equation that's linear in y would be to divide by this a sub 1 of x. You divide everything by this function of x, and you get dy dx plus a function of x times y is equal to a function of x only. This is the standard form for the equation. If it was linear in x, then you would solve it and you would have dx dy. You'd be dividing by this b sub 1 of y. You have dx dy plus, I guess I'll just call it q of y times x is equal to a function of y, and I guess what's another letter I can use? N of y. So you have dx dy, a function of y times x, and then a function of y only. You put it in what's called standard form, and then you proceed in that manner. So let me just look at a couple of examples, and I'll go through all the steps of what you do. After you put it in standard form, you're going to look for something that's called an integrating factor. And I'll go ahead and tell you how to find the integrating factor. To find the integrating factor, you do e to the integral of p of x dx, or if it's in this form, it's e to the integral q of y dy. You find the integrating factor. You're going to multiply both sides of your equation by your integrating factor. And then you're going to integrate and solve for either x or y. So those are kind of the steps that we're going to do. And I guess I'll just look at number, and I'll talk about some other stuff along the way. Problem 6. Y prime plus 2xy is equal x to the third. All right, this equation is not separable, so you've got to do something else. So you look and see if it is linear. You have y and its derivative to the first power. You have a function of x times y here, and you have a function only of x here. This is already in standard form, okay? Because y prime is dy dx. So if you prefer to write dy dx plus 2xy equals x to the third, that's the same thing. All right, since it's in standard form, you're going to find your integrating factor. To find the integrating factor, you take whatever is multiplied by y, and it's going to be e to the integral of 2x dx. And this is going to be your integrating factor. So this is e. When you integrate 2x to the x, excuse me, 2x with respect to x, it's going to be x squared divided by 2, so that's e to the x squared. You don't worry about a constant, you just integrate this, and it's e to that power. Now multiply everything in your equation by e to the x squared. And I also am going to multiply by dy, but I'll just do e to the x squared first. E to the x squared, excuse me, I want to multiply by dx. Okay, so I multiplied e to the x squared, e to the x squared, e to the x squared. Then I'm going to multiply by dx. So I have e to the x squared dy plus 2x e to the x squared y dx is equal x to the third e to the x squared dx. All right, kind of a check. You may want to check yourself when you're doing this. Over here you should have only x's. This should be a function of x with your dx. You should not have any y's over here at all, okay? Now, after you've done that, you multiply both sides by your integrating factor. The next thing we have to do is integrate. Now, you're going to have to trust me on this because we haven't really covered this in calculus yet. But when we integrate this entire side right here, the integral of this is the integrating factor, which is e to the x squared, multiplied times the other variable, which is y. That is the entire integral of that. Equals. This one over here should be something that you can calculate either by calculator or by hand. But if you want to integrate that, I would probably just stick it in a calculator. Integral of x to the third times e to the x squared. And if I wrote it right in my calculator, I have x squared minus 1 e to the x squared over 2. Oh, is anybody else doing it? No, y'all aren't doing it and you're using your calculators. Okay, plus a constant. Trust me on this, I guess, huh? That's not a good idea. Okay. All right, now we've integrated. I'm waiting for questions about this, but I'll go ahead and finish first. Solve this thing for y. Divide by e to the x squared. So I have y is x squared minus 1 over 2. I'll write it out. E to the x squared. I have e to the x squared over here plus c over e to the x squared. These are going to cancel. So y is equal to x squared minus 1 over 2 plus c over e to the x squared. Okay. Do y'all have a question on this right here? Or y'all just going to take it at face value?
So it's going to be like that every time?
Every time. Every single time. It is going to be your integrating factor times the other variable. The other variable in this equation is a y. Always, on this side. Alrighty, now there's a couple things they're going to ask you about. In this solution, they're going to ask you if there are any transient terms in your solution. So let me try to explain to you what a transient term is. A transient term is a term that is going towards 0 as the x's get larger and larger and larger. It's kind of like looking at a limit. So a transient term is a term that's going to disappear. This one is going to get bigger and bigger and bigger. This one is not transient. But look at this. This is a constant divided by e to the x squared. E to the x squared, as these x's get larger and larger and larger, this whole fraction is going closer and closer to 0. So this term right here, this one, is the transient term. And if you're asked for transient terms, which are going to be on WebAssign, you just pull it out and write it, whatever it is. That is your transient term, because it is approaching 0 as x gets larger and larger. Okay, another thing they're going to ask you about is the largest interval over which this solution would be valid. To decide that, you go back to your original problem. If what you're worried about is any coefficient that's right here, if you have an a sub 1 of x, if you have a function. Because what you do, since you divide by that a sub 1 of x, if it's a problem, you might be dividing by 0. So what you're going to look at is this first term, anything that could possibly be 0 anywhere. In this case, you don't have anything there. So the largest interval over which this solution is valid is all real numbers from negative infinity to positive infinity. So you give interval, you look at transient terms, and you write your solution. Okay, let's look at some more. This one is number 7. X squared y prime plus xy is equal to 1. This equation is linear in y because y and its derivative are the first power. The coefficients are x's, but it is not in standard form. What you're going to have to divide by is x squared. So that means since you're going to be dividing everything by x squared, you're going to have to look at the singular point. What is going to make this turn into 0? 0. So a singular point is if x is equal to 0. That means when you're splitting your number line to look at what interval this would be valid, you look at positive numbers greater than 0. So the greatest interval would be from 0 to positive infinity, because you're going to divide by x squared, and x squared will be 0 when x is 0. So to put this in standard form, y prime plus, if I divide by x squared, I have 1 over xy is equal to 1 over x squared. Are y'all okay with this interval business? And then what to look at? Look at this term right here, whatever turns it into 0. All right, now you have to get your integrating factor. It's in standard form. So this is the first thing we do. Second thing, integrating factor. The integrating factor is whatever is in front of your y. So e to the integral of 1 over x dx, that's e to the natural log of x. Technically absolute values, but we don't worry about it. This e, remember properties of logarithms? I told you that when you had something like this, the value of that is only x. So your integrating factor is just x. So now, third thing you do, multiply this by x. So x dy dx plus y is equal to 1 over x. If I also multiply by dx, I get that. It's going to be x times the other variable, which is y. So you can't forget that. It's x times y equals, all right, the integral of this. The integral of this is the natural log of x plus, you can either do c or natural log of c. You solve this for y, so y is the natural log of x over x plus c over x. Question? Let me go back to this for just a second. I think it's easy to see if you had this. All right. I'm telling you that if you integrate this, you're going to get x times y, and y'all are trusting me. But let me just, for just a second, if I look at x times y, and I think of it as a product, and both of these are functions, you would use the product formula. We haven't gotten to it in calculus, but remember it's first times the derivative of the second plus second times the derivative of the first. All right, first times the derivative of the second is dy, plus the second one, which is y, times the derivative of the first is dx. So x dy plus y dx is x times y. That's why. Sort of. Okay? Alrighty. Now back to this. After you get to this point, they're going to ask you for transient terms. All right, this one is going to be transient for sure. So this one is transient. But you also have to look at this one because you've got x's in the denominator. What's happening here as these get larger and larger and larger? Is this thing disappearing? Well, you've got bigger and bigger and bigger over bigger, 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 bigger. All right, you really need to use L'Hopital's rule to look at this. The derivative of the natural log of x is 1 over x. The derivative of x is 1. As this gets bigger, this is 1 over x. As x gets bigger, what's happening to that term also? Isn't it going to 0? The answer is yes. This one is going to 0 also. So as your x gets large, both of these are actually transient. Because both of them are going to disappear. So I looked at L'Hopital's rule right here to decide what's happening. You guys still with me? Let me look at another one. Number 16. Y dx is equal to y e to the y minus 2x dx. Oops, dy. Wait a minute. This is dy, sorry. Okay. Now this one is not in standard form, and it's not even in a really very useful form. I've got to decide if it's linear in x or linear in y, because I've got y's and some and dy, and then I've got x's and dx. It looks to me like it's going to be linear in x. So I would try to set this one up with dx over dy, because I've only got this here. So if I try to maneuver this one, dx divided by dy, then I need to move this 2x to the other side. Because I need x and its derivatives. I need function of y, and only y's down here. All right, so this one looks like it's linear in x, so standard form, divide by y. Okay, with me? Divide by y. Thank you. Totally left that one off. Yes. Thank you. Okay, your integrating factor is going to be what's in front of your x. So the integrating factor e to the integral of 2 over y dy. That's e to natural log of y. Properties of logarithms, remember this is e, the natural log of y squared. This e and this natural log will essentially cancel and leave you with just y squared as your integrating factor. Is everybody good? Multiply everything by y squared. And I'm going to multiply by dy at the same time. All right, if I multiply y squared here, that's going to be 2y x dy, y squared e to the y dy. I think I multiplied it right. So, by definition, this left side, the complicated side, all of that is your integrating factor, excuse me, which is y squared multiplied times the other variable, which is x, equal to integrate this side. Use your calculator or whatever. Looks like I'm going to get y squared minus 2y plus 2 times e to the y, I think, plus constant c. Then you're going to solve this equation for x, because you've got y's everywhere else, so divide everything by y squared. X is, let's see, that's going to be, I'll just do it like this. We did not look at the interval, and then we need to look at transient terms. Okay, transient terms, I think the only transient term here is going to be this one. Is c over y squared. This one. Because this one is not going to go to 0, because this e to the y is getting bigger and bigger and bigger. So that's the only thing that's transient. The largest interval over which this is defined, if you go back to my original problem, right here I divided by y. The only thing that will make this 0 is 0. So the largest interval, again, is from 0 to infinity. And that's also what's going to make this denominator turn into 0. All right, questions before I do an initial value problem? Okay, let's look at, I pulled 26 out of the book, so let's see what that is. dy dx is 2x minus 3y. My initial condition, y of 0 is 1/3. Remember, when you have initial condition, you have to find your constant. See? All right, to put it in standard form, this is linear with y. So y and its derivative need to be on the same side of the problem. So I'm going to move the 3y. dy dx plus 3y is equal to 2x. I needed to work one with a negative. All right, one thing I've not done, I've not worked one where there's a negative right here. If there is a negative, if this had been plus and this had been minus, okay, that negative has to be used as part of your integrating factor. Okay, did y'all hear that? If this is negative, use as part of your integrating factor. So you would put e to the negative whatever that is and integrate that. If that's negative, take the sign with it. All right, so that's standard form, integrating factor. It's whatever is multiplied times the y. So the integrating factor is e to the, excuse me, It's e to the integral of 3 dx, which is e to the 3x. Multiply everything by e to the 3x. Again, what I did is I multiply by my integrating factor e to the 3x, and I multiplied by dx to get it off of the bottom. By definition, this is your integrating factor, e to the 3x times your other variable, which is y, equal to, integrate the other side, I wrote it down right, 2 3x minus 1 e to the 3x over 9 plus c. Did you get that? Okay. Go ahead and solve it for y. E to the 3x canceled out. This term is going to be transient. They're not going to ask you that. They are going to ask you the largest interval over which the solution is valid. And the largest interval is negative to positive infinity. We didn't divide by anything that's going to mess it up. All right, it had an initial condition, so you've got to go back and use your initial condition. The initial condition is y of 0 is 1/3. So that means x is 0 and y is 1/3. So substitute in. 1/3 is equal to, all right, that's a 0. If that's 0, that's going to give you c. So 1/3 is equal to negative 1/3 plus c, so it looks like c is 2/3. That's 0, so that's negative 2 over 9. Why did I do that? That's not right. Whatever 1/3 and that is. Is that 5/9 maybe? Is that better? I was adding 1/3 plus 2/9 to get 5/9. All right, so then your final solution, therefore your final solution is y is 2 3x minus 1 over 9 plus 5/9, and I can write that as e to the negative 3x. And that is your final solution. All right, that's how you solve a linear equation. Do you need any other examples? I think I've helped you answer the questions. They're going to ask you transient, they're going to ask you the largest interval, and then they're going to ask you to put the solution in there and tell you whether to solve it for y or x.